Okay, so this video continues on from the dataset internal structure video. And I've gone back to the predefined on the A scan. And now we're going to have a look at how the build data set works. Okay, so this is the internal structure of the data set. And I'm going to scope up to the data manager here. And if you look through these items, you can see that the internal structure of the build data set follows that of the data set, except for this one node, which we'll discuss. So you get the basic idea of the build data set is it makes an internal structure here, then configures the connected data set in the same structure, and then the last step is this extra object here, which fills it with data according to a script. Okay, so let's look at the build data set, and this is on the node, and there's two properties here, number of subsets and number of scan axes. And as we saw in the last video, the scan axes are the ones that live on the data set, not the subsets. So we could modify this one by putting one subset here. And I guess we'll keep the defaults, except we'll put the units at millimeters. And we will run this node. And now you see that we've got an extra axis on the data set, and you can see, as expected, it's up here. Okay, so you could go on, and then you could change this to add a second data axis if you want. We could add a second subset, and you can see that now we have two subsets. The second one doesn't have an axis on it, so it's only got one axis in the data set, and then none in the subset. And that's how we configure the root. I'm going to go back to one subset here, and then I'm going to drag out, look at the properties of the subset inside the builder. And again, it's just giving us some properties that let us allocate the structure of the data set. So number of scan axes is 1. You could put that to 2, which would give us a sweep axis. We could put degrees here. And, we could change it to, let's change it to a 16-bit integer. And we'll run that. And we have three-dimensional data. You can see if I hover here, the data is 16-bit, and I've got my two axes on there. Okay, so that's how you build the structure. You can make the structure you want pretty easily. Now let's look at the contents of the data. And I'm going to go back to the predefined on the A scan and run that. We've got something a little simpler. Maybe I'll leave that there. Okay, so if we drag out the subset here on the builder, it's giving us the shape of the subset, but it's also giving us the contents. So this fill script is in this property here. It's showing on this editor window. And what it does is it calls tasks on this data injector. And so we'll start by looking at the data injector, and we can see that it's pathed to data subset or data set and subset 0, so this data set. And if we right click on the data injector, you can see that there are a bunch of tasks. And there's add value. And so basically, when we do the build, the builder takes each line, passes it in as a task, and that data injector will call the task, and in this case fill it all with a 0. So we start by filling it with a 0, and then it will add 3 pulses, as you can see. And the other thing it does is that under the hood it will loop through the subsets there and fill these properties in for you automatically and call the tasks for you automatically. So it's useful to know that this data selector you can use to populate any subset with data. In this case, it's automated according to this script, but it's not particular to this situation. Okay, so the tasks you can see here on the data selector. You can also use the task on the subset here, saying add fill task, and I guess we can let's do another pulse, but you can see the fill task. So add a line would be drawing a line probably more in 2 or 3 dimensions than our 1 dimension. Noise just adds some noise to the background. Pulse is what we're seeing. A sine wave is continuous. Add to region would be adding a value to a certain region, and so on. There's a bunch of them. Set value does a single point, sets a single point. Rectify rectifies the data. So there's a lot of tools in here, and they're fairly obvious. But let's do one to see what it looks like, and we can add a pulse, and it shows up over here. So one thing to note is that in these tasks, you can either call the arguments in order or by name, and so the name obviously makes it a little more explicit as to what's going on, and we can see them for the automated tasks. You typically aren't, the automated tasks that fill these up, you're not going to look at them typically, so they don't, they're done by order. So peak, it's the number of cycles, it's a peak, the amplitude, and all these positions are in pixels. So this one's going between 500 and 600 pixels. So if you can see the new pulse that's shown up there if you haven't noticed. So let's do to 6 to 7. And then off screen here, it's got Y and Z values and phase. You can change the phase, and then W at the end too, which would be if you had a 4th axis. So let's just change the phase for fun. 45 brackets. It's semicolon delimited, and you run this again and see what happens. You can see the phase changed. The peak property here is for the 2nd and 3rd axes, so it will, if you're doing Y from 10 to 20, it's whether that's got a smooth peak to it or just hard cutoffs. Anyway, let's try. We'll look at one more. We'll look at this C-scan, since that one's a little different. And this one's done a fill region, or several fill regions, and it's got a different fill region on the 2nd output. So let's just we'll just look at that task again. So we'll go add fill task, and fill region is the first one. So rectangular means a square shape. Circular is a circle, but it's a step circle, and this is the one we're on peak. So 0, 1, 2, and that's peak. These are all set on 2. X, and then our values are x start, y start, x start, x end, and y start, y end, z start, z end. And that's what these ones are. So let's just try a few things. We'll make this one 87, so it should get bigger. And we'll do 0, which should be a rectangle. And we let that run, and that seems pretty reasonable. We can put this over to a 1, which is a circle, but without just the hard edges, not the tapered edges. How about this one? The y goes from to 13, so we can put that to 18. It should get a bit taller, and so on. Anyway, pretty straightforward. Like I say, they're always in pixels, so you have to figure that one out. But I think that will hopefully get you started on using the build data set.